So our second speaker today is Max Duzyk, who is the Global Director of Building and Science for Huntsman Building Solutions. Max has travelled all the way from Canada to be with us today, and he's here to talk to us about the different types of PU and their applications. So if you could welcome Max to the stage.
Well, thanks for the introduction. Very nice to be here today with you. So we really appreciate the opportunity. And I just want to thank the PCA for organizing this conference. It was very well organized, so I think it's worth a round of applause. So today we're going to review the use of PU foam as a water and radon barrier. So if we look at the agenda, so we're going to review quickly the difference between open and closed cell spray foam insulation, interior foundation applications, exterior foundation applications, and then under slab application for radon protection as well. So open cell insulation is a low density, is more flexible. I think you are more familiar with this product here in the UK. Closed cell insulation, that's what we're going to review today. So it's a harder product, so medium density. So open cell insulation usually is installed in roof, walls, crawl spaces, exposed floor, not in basement or rim joists usually. It is mold resistant, it's low VOC, it's breathable, meaning it's not a vapor barrier or not a vapor layer control. It does provide sound control, and it's an air barrier material as well. Closed cell insulation, so it is an air barrier as well. It's water vapor resistant, meaning it doesn't need an additional vapor layer control. It's radon barrier. It does act as a water resistive barrier as well for above grade wall assemblies. It does include recycled and renewable content. It's also low VOC, mold resistant, and does have a high compressive strength. So if we look at the interior foundation application, usually this is one of the most common application for closed cell insulation, especially for the rim joist, since the floor connection with the foundation wall is often really hard to seal with different types of product, either sealant, tape, or whatever. So spray foam seals everything, so that's the big advantage. And same thing for the foundation wall. You have a perfect adhesion of the product to the concrete, so that reduces the risk for condensation. So the Canadian government has studied the interior application of closed cell insulation. Many houses and buildings were studied, and many of those buildings had application for more than 20 years, or the application had been done more than 20 years prior. So the conclusion of the study was that the performance of the product was still good. It had not deteriorated, and the adhesion was good as well. FEMA as well rated closed cell spray foam as a class 5 material for flood resistance. So FEMA evaluated all types of insulation, and closed cell spray foam was the only one that was rated class 5, meaning that it can be clean and can be kept following a flood event. So in 2017, there was a huge flood in Montreal where many houses were flooded with more than 5 feet of water. As you can see here, furniture was floating around. After the flood, we have been called on site because many of these houses had spray foam insulation in it, so closed cell obviously. During 5 days following the flood, this house was dehumidified and ventilated. So when we came on site, what we did is that we took samples, spray foam samples, measure the humidity content of these samples, verify the adhesion as well. So the spray foam, they had not absorbed any water. So we were able to keep the spray foam. We measured also the wood structure for humidity content, and the only portion of the wood that still had a higher humidity content at 30% was the portion that was embedded in the foam. So all that it needed is additional ventilation and dehumidification for a couple days. So then all that was needed to be removed was the interior finish, and they replaced it. So the insulation and the structure was maintained following the major flood. So with other types of insulation, probably it would have to be removed. So if we look at exterior foundation now, this is also a common application that we see more and more, especially for retrofit or even new construction. We can apply spray foam below grade. And then you have, closed cell spray foam is not a waterproofing product, though. It needs an additional barrier, and we'll see this in a few slides. But this is a typical application for exterior foundation. Same thing for old foundation or stones foundation. This is the perfect product for these types of foundation because of all the gaps and the unevenness of the surface. Other insulation product would be hard to install for this application. So with the good adhesion of the spray foam filling all the gaps and cracks, this is the perfect solution for these types of foundations. So the Canadian government also studied this application, the exterior insulation with closed cell spray foam. So for 2 years, they studied a project, and there was no waterproofing product, either on the foam or on the concrete. So it was only closed cell spray foam. So the conclusion of the study was that the foam remained dry, it performed as intended, and the adhesion was good for the period of 2 years. So that's really confirming the durability of this application. Okay, a quick video now. So this is what I was discussing when I was talking about water-resistive barrier for above-grade wall assemblies. So this is the ASTM E331 testing where we spray a huge amount on the wall assembly. So spray foam is exposed directly to the water, and all along this testing, there's a negative pressure of 300 Pascal that is trying to pull water inside the wall assembly. And as you can see, there are many details like penetrations, like a window, brick ties, Z-gird, and vents. So all of these are kind of the worst scenario for a wall assembly like this. And once you have a cladding installed, you'll never get these conditions on site. So after 15 minutes, there was no leak at all behind the wall assembly. So that means that spray foam successfully passed the water infiltration test for above grade wall assemblies. So still, exterior foundation, as I was saying, closed cell spray foam is not a waterproofing product. If you want to get a full waterproofing system, you need to apply a waterproofing membrane on top of the foam. So it could be a polyurea system that we manufacture as well. These are the two images on the right. If not, it could be a bituminous product or a sprayed applied membrane. Spray foam is compatible with bituminous product as opposed to board stock insulation, which will melt when in contact with bituminous products. And one question that we get often is how do we finish the above grade portion of the foundation wall? So usually, as you can see on the image on the right, we will install Z-gird directly on the foundation, spray the foundation, and then install a light cement panel with an acrylic coating to provide the exterior finish. Okay, talking about radon, I think you're all familiar with radon. So radon is the second cause of lung cancer after smoking. It's a heavy gas, and usually it will stay in basement or any part of building that is in contact with the ground should be protected against radon. So radon can infiltrate through the foundation wall, through the cracks, through the slab, through the connection of the slab with the foundation wall. So it's really recommended to have a radon protection system in basements. So a great solution for that is the use of closed cell insulation applied on the gravel, directly on the gravel, and the full system with the foundation wall and rim joists as well. So the advantage of this is that you get a full continuity. So the product from one side of the building to the other, it's the same product without any joint. And then it self-seals as well, all the penetration through the concrete slab. So all the piping is self-sealed. So you don't need any tape, any sealant. That's the only product that can provide this type of sealing. So just before and after picture, so you can see that the basement is completely sealed. As I was saying, no joints at all. So really preventing radon gas from entering the building, as well as insulating. So the Canadian government also evaluated this application for radon prevention and provided the CCMC evaluation, which is similar to the BBA or Kiwa evaluation here. So it confirmed that the product was a radon barrier for an air barrier and then puncture resistance as well. And we'll see this in a second. So other question that we get is it compatible with heated floor? So yes, it is. Whether it's a water heated floor or an electric heated floor, it can work. As you can see, usually it's installed on top of the wire mesh, and then once the concrete is poured, it gets lifted in the middle of the concrete slab. So mechanical damage, as I was saying, spray foam resists well to mechanical damage and puncture. As you can see, when workers are pouring the concrete with their boots, with the shovel to lay down the concrete, thinner membrane can easily be punctured. So as opposed to spray foam insulation, where you have 2 inches of product, so it's much harder to puncture than other systems. Okay, so we're going to see a quick video of the radon testing that we did. So this is the pipe usually that is recommended to be installed in the gravel. This is a 4-inch perforated pipe that will be linked to the middle of the basement. So if ever radon gets detected in the basement when the concrete slab has been poured, they will use mechanical ventilation to depressurize under the slab and extract the radon either at the rim joist or through the roof. So this is the perforated pipe that runs through the basement up to the middle of the floor slab. So what we did instead of depressurizing is that we pressurized the system with smoke, because we wanted to show that the smoke was traveling below the foam up to the middle of the basement. So this is the equipment that we used. You'll see when the pipe moves is because we inject the smoke at this moment. And you can see the smoke follows the pipe where it was installed directly and exit through the gravel. So after that, we sealed everything with spray foam. So all of the gravel was sprayed with closed cell insulation. And then we left a 2-feet strip in the middle of the basement uninsulated. So as you can see, when the camera will turn, the smoke is coming from the left side of the building and moving below the spray foam and exiting only where there's no spray foam. So that could be radon gas, for instance. So it really shows that the spray foam is performing well for the radon prevention. After that, we just removed the sample to show the thickness of insulation that was installed. as well as the adhesion to the gravel. So you can see the gravel sticks to the foam or the other way around, and you have 2 inches of spray foam all across the full basement. After that, we measure the pressure. You can see the pressure is around 200 Pascal. We just place back the sample to its original position, and you can see that the pressure increases, but it's not perfectly sealed yet. So now we installed tape, just like we would with board stock insulation. So you can see the pressure increases still, but it's not yet at its highest. So then after that, we completely sealed everything. So we just sprayed the sample that we took, we sprayed a hole. So everything is now perfectly sealed. There's no joints, no cracks, no hole. And you see the pressure is now at its highest, at 400 Pascal, which is really high. So the pressure is pushing under the foam, and you can see what's happening. The foam gets lifted by the pressure, but still it's not cracking, it's resisting well. And with the weight of the concrete after, it's going to be even better. So you can see 400 Pascal still. And then that's the pipe that is communicating with the gravel. You can see the smoke that's coming from it. So it means that all the smoke was maintained below the spray foam. There was no smoke in the basement. Just typical commercial applications that we do. It's not only for residential construction, commercial jobs like fire station, aquatic centers, warehouses or school. They all use the system for radon protection, but for insulation as well. Online information, so maybe you know this website, but if you want to get more information for the UK about radon, there's a nice website where you have a lot of documentation, an interactive map as well. So if you want to see where you are located in the UK and see exactly if there's a high risk or a low risk for radon, you can use this website. We do have a lot of documents available as well for radon protection, case studies for floods, and exterior foundation for a great waterproofing solution. So all of these are available on our website, but we've also created a special web page for this conference. So if you want to get the information, you can just scan the QR code. It will lead you directly to all the documents that we reviewed and even more. So with that, thanks a lot for your attention.